You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey everyone, I'm so excited today. We're going to be talking about Apache Iceberg and Apache Flink. And joining me for a discussion is Adi Polak. And Adi is Director of Advocacy and Developer Experience Engineering at Confluent. Adi, it's so nice to have you here.
Thank you so much for having me here, Alex.
You know, we've heard so much about Iceberg as of late. What's that all about?
Yes, absolutely. It's a really interesting technology that, came out of Netflix. I'm not sure if you're familiar with the history, but it came about some years ago with some fantastic engineers in Netflix that wanted to solve the atomicity problem. So what happens when you're doing big data processing, you get a lot of temporary files that you write into your S3 or other cloud storages. So initially, Iceberg started as a solution to solve that atomicity. And since then, it grew and grew and grew. And we can see now a vibrant community around this product and also many contributions from different companies in the world that helps develop Iceberg, which I think is the most interesting bit of it. It's not only Netflix kind of leading the way into how to do best practices around storage, but also other companies help define that as a standard in the industry.
Cool. Well, why don't we move into the slides? And for all of you who are listening to this, you can actually see these slides on our YouTube page at The New Stack. And so we're going to just move along here. I expect most of you who are listening will be able to follow what we're discussing. But if you want to see those slides, please go to our YouTube page. So let's get started. Now, I was really interested in this topic and how it relates to where we are today, because I do see the distinctions that you're showing here. Could you tell me a little bit about the differences between the operational estate and the analytical estate?
Absolutely. So if you take a step back, looking at data infrastructure, data architecture, we can at a high level split them into operational estate. This is where microservices lives. This is where our event-driven application live. This is where our stream processing is taking place. We care a lot about being fast. And we care a lot about throughput. We care a lot about latency. So this is our operational estate. And on the other side, you have the analytical estate, where we have long jobs that can take sometimes hours to process. They crunch weeks of data, days of data, multiple hours of data as well. And this is usually from an application point of view. Usually these are reports or some decision-making process that we are willing to wait a couple of hours to get the information. And it's not necessarily where we need it right now. So this is where our analytical estate lives. And if you look at the diagram here, you can see there's a little bit of a chaotic feel to it.
Yeah.
For a good reason, because what happens, we call usually the operational estate, we call upstream, and the analytical estate, we call downstream. So what happens is a lot of our applications are talking with upstream and downstream, and there's point-to-point connections that oftentimes break because software.
Yeah.
Software always, something is bound to happen at any moment.
Exactly.
So this is what we're saying here, like the little bit of a chaotic space of data estate and what's really happening in organizations with this different estates.
Yeah. So like the operational estate is like a SaaS application, right? Or an ERP or some form of transactional database. Would that be correct?
It can be. It can also be, multiple microservices that we chain together for building an e-commerce, for example.
Which would be more relevant, I think, for our discussion here. And then the analytical estate, would that be like a data lake?
It could be a data lake. It can be a data warehouse, for example, where, let's say, there's some executives and they have a BI team that crunches, 3 weeks of data in order to produce a quarterly report, for example.
And so in the operational estate, how has data been represented through streams? Is that using Apache Kafka?
So some of the data it's been moved using Apache Kafka through the producer and consumer mechanism that we have. And representation can be many types. It could be JSON, it could be Avro, it could be protobuf. One of the interesting things that happen in the operational estate is we don't always have the notion of schema. And schema is something that we can add as an after effect, or we can add as we go. So this is why tools, if you're familiar with tools like schema registry, where we want to have a contract between the different applications on how the schema is built, what the different types that we can expect to have there, and so on. So yes, we have lots of Kafka. We also have the notion of schema registry. We also have in the middle, we have Flink as well, and applications that we're developing.
And so in the analytical estate, is data is stored how? Is that stored in tables with Iceberg then?
Yes. So in the analytical state, what we have is well-defined tables. Oftentimes, we want to have well-defined tables. Sometimes, and this is where the chaos comes in, we have raw data that it's not yet well-defined, but it is on the way or in the process of being defined. And we have different file formats like Parquet or C. And so Iceberg is the layer on top of that helps us you can imagine it like a very lightweight layer on top of the tables, on top of the storage that we have in the analytical estate that help us define the contract of tables, the notion of tables. If the table itself, the data is distributed, so which files are related to that specific table, which version, which columns are in the table, and also some matters of statistics. And statistics here are important because when we are creating analytical query, you can imagine any SQL query that an engineer would want to write to query the analytical estate. Then the data later on is being pulled out of tools like Iceberg. So the statistical data is being pulled out of tools like Iceberg to improve the performance of the query itself. So it doesn't go and try and scan all of the data lake. It will only pinpoint to the exact files that it needs, which you can imagine how it saves cost and time and potential errors.
Huh. And you mentioned Flink, and Flink, as I understand, can be used for both batch and real stream processing. And so does that play a part in how it fits into the analytics estate or the operations estate? Is it more, or is it both?
That's a really interesting question. So at its core, at the bottom level, Flink was created to work as a stream processing engine. So if we think about abstractions of how Flink itself is being operated, at the bottom of the abstractions, we have things called events, right? Because we care about events, we care about once, and other types of events. We care about the state. It's very strong in stream processing. Are we running a stateful application? Are we running a stateless application? And the last abstractions is around time. How do I perceive the notion of time when I'm running stream processing? Because we care about latency.
Yeah, and that probably plays into some of the following slides. So let's move on. And we talk a little bit about operational state being, something that Kafka is known for, and Iceberg for the analytics estate. We haven't really defined each one of those, so maybe this is a good opportunity to discuss that a bit.
Yes, so I believe the best phrase for Kafka is data in motion. Helps us move data from place to place. and being the reliable source for all our applications around data. And this is the key in operational state, and it proved itself again and again. It's a de facto standard for the basics of data streams and moving data around. On the other side, on the analytical estate, Iceberg recently emerged as the open table format. It's kind of like the layer that sits on top of storage for the analytical estate. So this is kind of like the separation between them in terms of the different estates.
Mm-hmm. Within the operational estate, there must be more data governance involved, or is it both operations and analytics where there needs to be thinking about the data governance? I would expect them both.
Yes, Alex, that's a really good question. And, one of the questions that always comes up is, what do developers define as governance?
Yeah.
And that's a big topic, because one governance can be, am I adhering to the compliance of how I handle data, right? And now in the USA, different states will create kind of like their own compliance mechanism around data governance. Another aspect of it is more of a simpler an abstraction is, do I know what's happening with my data? Do I have kind of like a catalog of all the ETLs or data streams happening in my organization? Is there a place where I can see it? Can I tag it? Can I get a lineage of what happened to that data? So one, you can imagine, one is a very static one. It's like my data has to comply with the GDPR and, other aspect. The second one is a more dynamic one. Is now my engineers building, and I want them to build because, they're building, at the end of the day, they're building a product
Right.
that business is going to take forward. And we still want to have some governance mechanism to understand what happens, what's the lineage, where is it going. And so I believe governance, in different flavors needs to be in all of them. And governance specifically on the streaming capabilities help us manage a lot of the complexities early on. Even if you think about compliance, so if I have some of data that is considered more sensitive, data that is considered GDPR sensitivity, I can add a tag to my data streaming pipeline and say, because it handles that specific table that I know of, it has attached sensitivity to it. So when we're bringing in, any executive that works in the data, which needs to make decisions around it, they have easy view to understand what is happening in the organization, and they can mitigate risks, they can solve problems. So my take is it needs to exist in both. And in order to be more efficient, we need to solve it first in the operational estate and have a more dynamic approach to it, rather than taking inventories and after effect. That I also seen that happens. In some of the developer communities.
Yeah, and I guess back to what you said about defining data governance and what it means. So, for example, in Apache Iceberg, as I understand, it's ACID compliant, right?
Yes.
And so I would expect you would expect that from a technology that's storing in an open table format. And I wonder then, is that why we see Iceberg being used for analytics as opposed to operational technologies?
That's an interesting point. So the governance aspect, as far as I know, in Iceberg is through a pluggable catalog or pluggable mechanism. And because of their ability to add, so the community pushed very strong to add what we call REST catalog implementations for a plugin. There's a JDBC one and there's the REST one. And on top of these catalogs, we can create or enforce some mechanism related to governance. Because again, view into the tables and so on, which is very interesting to see. But again, it's not necessarily out of the box in the open source solution right away.
That's where the community plays such a big role, doesn't it? Because they need to define the priorities.
Yes, 100%.
And not everyone's going to be happy, but that's another story. So this is where we can get into this data mesh, isn't it? This developer pain that you're referring to a little bit about, what do you, how do you think about this data? How do you think about, what its role is and what each piece of data, what each artifact really represents?
Exactly. And the point-to-point mechanism, for example, schema evolution. My schema changed upstream and now it's impact downstream. Someone in my upstream changed something, but they're not communicating with the downstream. How can we build a healthy contract between those two states? And also reflecting back on how engineering teams are built, usually you'll have different teams working on these different estates as well. So it becomes kind of like a engineering organization challenge sometimes.
So when you're talking about point to point, for instance, traditionally we've seen point to point with ETL, right? And is this something we're going to get to later in the slides? Because I'm curious about how we think about that point to point issue, because there's a lot of ways to think about point to point architectures, isn't there?
Yes, and we're getting into it in the slide. We have one slide with more of a high-level architecture that we can dive in, where we can talk a little bit about separations of ownership and how to build those points exactly this way. And how to build those points in a way that is sustainable, scalable, and manageable. And this is exactly it. What you can see in the middle, we have the data stream and we have the data products. And this is a little bit of a philosophical question of what are data products? And in the industry, there are different views, right? In the financial world, the data product can be bank transactions. In the healthcare world, the data product can be my patients or their prescriptions. It can be many things that connects back to the business. And then the question is for us engineers and developers, how do we take that very businessy approach and bring it into our engineering, or how we're building our data infrastructure? Because there's no one generic data infrastructure that is going to work for everyone. We always need to do some fine-tuning, some adjustment according to the data that runs in our pipes. And so having here the notion of data products, how I think we need to simplify it is, I have my Kafka topic, I know what it's dedicated for, and then I have my schema registry. And together with that, I can add the business knowledge on top of it. This, topic is for patients, and this is the schema, this is what exists there. So this becomes my data product that I can nurture and take care of and make sure it's, well tagged within my governance aspect, so I can build it.
So and that's what you're referring to here a little bit, right?
Exactly. Like connecting how business impacts our engineering work in the day-to-day. And so when I have my Kafka topic and I have my schema, and I know this Kafka topic is specifically dedicated for prescriptions, so I know I have this one data product that I'm nurturing around with the rest of the data products like patients, drug stock, accounts, diagnosis, providers, and so on. Of course, this is a very high level healthcare organization that acts as an example, and each organization will have its own specifics, but it can help me make the right decisions around my architecture and start building. And so instead of having many points or point-to-point connections, we can have a more kind of structured and organized architecture around this data product. So I know it kind of acts as a contract. So when I know the downstream or the analytics part nurtures these tables and nurtures this information or pulls information out of that, they know exactly what exists there. And when the upstream, my operational estate, reads and push data into these data products, again, there's a known contract there that we can enforce that helps us create this healthy conversation between the two estates. So that touches a little bit about this architecture where, we've been using a lot of Kafka and we're going to continue using a lot of Kafka as an engine for us to help move the data in the analytics and in the operational estate. We also are aware that now there is Iceberg, where we can also push or sync data directly from our data products into Iceberg and later on represent it again as a data product. And this thing is immediately get exposed into the analytical estate that already knows how to work against Iceberg.
When you're talking about this, I'm thinking about the programmability of the data. And
Yes.
also then when you're talking about schemas and being able to, to define where the data goes, I think about metadata quite a bit.
Yes.
I guess that's relevant.
Yes. Metadata helps us understand what exists, right? Help us understand the statistics of our data, right? Sometimes it's very important for us to know how we defined the data products to start with, and actually it stands together with the quality assurance of what actually exists in my data. And that touches a little bit about data quality as well. If we think about it, because at the end of the day, one of the important aspects of a data product is making sure that it's high quality. And so addressing that early on where we're building the data product is really critical, because then when it goes downstream to the analytical estate, the people that pulling the data from there already know the quality of that. So a metadata talks about where is the data, what exists, what are some statistics, but another layer that we can add, some engineers already added it, it's the confidence in the data. If I don't have confidence, how do I build this confidence early on when I know the data is being streamed from upstream all the way to downstream? So adding this quality assurance and quality checks early on as well to build that mechanism into my architecture. I'll say that changes a little bit how we work today with data infrastructure. It's sort of like a shift left. It's like moving some of the some of the ETLs that we do in the analytical estate and bringing it early on in the conversation into the operational estate, because before the data lands into our data lake, we can already make sure it has high quality and all the guardrails necessary for it.
Well, we could probably talk a lot about platform engineering in this context and how that plays a role in helping manage the data for the developer. But I guess we could save that for another time.
Absolutely.
This might be a good point just to give a little bit of an overview on Iceberg and what it consists of. We've talked a little bit about it, but it'd be good, I think, get a little bit more context.
Yes. So out of the box, like I mentioned, Iceberg is considered very lightweight. It's kind of like a spec and a contract, what I have there, which tables, who manage them, how do you get access to them, and so on. So this is what makes it so applicable to people to start using it. And it's an independent storage layer on top of my storage layer. So if I have the separation between storage and compute, it's kind of like this thin layer in between that helps me know where my data is and also manage some of the aspects of the data. So we have the ACID transaction, but another aspect of that is compacting data. When connecting to any engine that can help us compact data, Iceberg also take notions of, if we have small files, if we need to compact the data, if we have, any potential issues there. So I think that's a very strong mechanism as well that acts as part of my storage. So it helps us manage it in a slightly better way. And like I mentioned, there's Parquet work in Avro support. And again, it can be on top of AWS S3. It can be on top of Azure Blob. It can be on top of GCP. It can be on top of MinIO. There's a lot of different implementations. And the community constantly contribute to it. So people created migration tools to help move catalogs from one to the other because of the pluggable capabilities in Iceberg. Community also built tools to analyze the health of your storage, leveraging Iceberg. So a lot of things have been built, and more things are going to be built, which I think makes this project exciting. Yeah.
Has lots of adoption.
Lots of adoption. One thing I haven't mentioned is the Puffin format. This is kind of like a blob of statistics and metadata that it on top of the existing metadata that Iceberg has. So enables us to add even more statistics that we didn't think about before. Sometimes also contributed by the community. We have support for all the big engines. There's also support for Flink. So from Flink SQL, you can connect directly and create a table or change tables. You can also bring data from your Iceberg tables back into Flink for stream processing. So if we're thinking about, having enrichment of a stream or anything that we can do, or anything that we want to query against Iceberg, that exists as well. And this is a community contribution on both sides. Both the Flink community contributed support for Iceberg, and Iceberg community contributed support for Flink.
What's always interesting to me is these technologies actually have been used for a while, haven't they? I mean, you see that in lots of big technology companies who are, pioneer these capabilities because they need them. And I think that's what we see now, isn't it? I mean, especially with, the interest in generative AI and more advanced automation. We need ways to better, tabulate our data, better to get the most out of our SQL environments, for example.
Yes, and we need to make sure this data is available for more practitioners in the organization, because you meant SQL, and SQL is a great language that many engineers are using. It can be the analytics engineer, it can be the data engineer, it can be the data science, it can be the software engineer in the organization. It's kind of like a common language that many practitioners talk within the organization. Versus, the other programming language where it could be a little bit more siloed. So SQL is a great language. And that brings me to talk about TableFlow. So TableFlow is actually a dedicated commercial Confluent capabilities where you can sync or you can convert your Kafka topics directly into Iceberg tables without writing any pipelines or creating your own sync mechanism just with a click of a button. So this is more for Confluent customers that wants to connect these two estates together. We're giving them this capability of TableFlow.
This is where, for me, where it relates again back to what I asked or tried to see if I was accurate about how to think about the heritage here of these technologies. And we talk about ETL. That must have been a problem that companies have had for years, who've been had to use ETL. They really didn't have anything else, but they then needed to start developing ways to think more about how to use streaming technologies.
That's true. And we're seeing it, it's interesting because it also speaks to the different applications, the different businesses that companies are building, and also touches on customer experience. I think in the last couple of years, what we see is an evolution with customer experience. Customers want their answer right now. So for example, if I have a flight and I'm commuting to the airport, I want to know if my flight is delayed right away so I can make decisions, right? Do I leave the house? Do I stay? Do I wait another 15 minutes? Am I going to hit traffic because of that? And so on. And the notion of real time became super important for the new applications that we're seeing today that customers want. So real time and streaming opens up the door for more businesses, better customer experience, better solutions, and at the end of the day, it comes, the request comes from the business. Like, I want this milliseconds answer decision being made right now because this is how my product is being defined. And so it trickles down all the way to the architecture. And then the question is like, how my architecture supports that request, knowing that, I cannot wait an hour to crunch the data.
Right. Right. The flight's
so-
already left the tarmac.
Exactly.
This looks similar to the slide that we saw before.
Yes, that slide speaks a little bit more about Flink aspect here and what is changing with Flink. And there's an interesting trend happening now where it's a kind of like a combination. Some of batch processing capabilities are being shift left into the stream processing. So things like quality assurance early on, governance, compliance early on, some more simplistic aggregations or simplistic filtering that we can do early on before we're landing that raw data in my data lake. So that's kind of an interesting shift that's being happening from the analytics estate into the operational estate. Another thing that is happening, it's a completely different space. This is the microservices space. So some of the microservices are actually looking into if they can move from being a microservices into being a Flink streaming app. Because a lot of my data, what's happening with microservices will come up or they'll always be up and they always try and query either Kafka or any other source that brings them information, do some processing, and then dump it back sync it into Kafka or any other, data collector or queue that I have there in-house. And so instead of doing that, we can leverage things like Flink for data streaming applications where Flink is always listening on a specific queue, always listening on data coming in. So instead of pull, we're now moving into a mechanism of push and making our system a lot more reliable and makes it even a lower latency because the system doesn't need to go up and load in memory. It's already there. It's always there. It's listening. And then it can process the data and much faster with all the different accuracies, the exactly ones and all the different accuracies that Flinks bring to the table. So there's an interesting trends now happening in the architectures. One is the shift left from the analytical estate into the operational estate. Another one is from microservices re-envisioning themselves as a stream applications.
Microservices re-envisioning as streaming applications. That's where Flink comes into play.
That's where Flink comes into play, and also batch applications or kind of like the problems that ETL solves that I can solve with stream processing before it lands into my data lake. So the data swamp challenge that we have.
Oh, data swamp. So tell me about Confluent and why have you adopted Flink and how are you building it into your core service?
Yes. So we always, monitor what happens with developer. We have a very strong developer strategy motion in-house. What developer needs, what is the real pain, where are the trends, where are we heading, what are real problems versus problems that, are more trendy at the moment that we're not necessarily sure there is a real problem in place. And one of the things that came out through, that research is Apache Flink. Apache Flink is gathering more adoption and solving real problems. We've seen some applications that moved into using Flink in the stream processing, either from a microservices world or either from the traditional ETL world. And that kind of ignite our curiosity around, should we start looking into it a little bit more?
So how would you sum up why Flink is gaining your attention.
Yes, so that means taking a larger look at our data streaming platform offering that we have. So looking at the data streaming offering is we have, of course, Apache Kafka there as a managed solution in-house. We also have governance. It's a very important aspect. We have Connect because you cannot build any data features or data capability without connecting to the larger ecosystem. And then the last one we have is processing. And Flink brings a processing engine into our data. So when we have the stream with Kafka, we also have the processing with Flink.
So now the concept of microservices allows you to use multiple services. And some of these services may be built in all different kinds of ways, correct? And so then that requires different ways to create the stream processing, doesn't it?
Yes, there are many different applications that developers can build today with Flink, with different Flink capabilities. Of course, not all microservices can be reimagined as a streaming application. Only the specific ones that related to processing data, maintaining state, being stateful, and so on. Yes, and it brings us the scalability of crunching data and being low latency and having the throughput that customers are looking for.
Yeah, that's the critical part of it, isn't it? So we've talked a little bit about Flink and how it builds abstractions for streaming through, and you just mentioned state and an event. We haven't talked much about events yet. Maybe you could touch on that a bit.
On events part, we have at least one, at most one, or exactly one. There's some different types of, when we think about events processing, we think about what is important for a product, and different products are going to define different events abstractions for us. For example, when we have a bank transaction, having exactly once is going to be critical. We don't want it most once, right? If someone deposit money or move money from place to place, we don't want that. We don't want to have at least once, right? If someone deposit money, we don't want to see it twice in someone else's bank account.
Right.
Or maybe we do if we're the other person. But, depends on the situation.
It eventually creates headaches down the road anyway. So,
Exactly. Calling the bank, spending many hours on the phone. Yeah. So this is where events are playing a key role here.
And then you get into state. And so we've talked a little bit about state, but you need that state.
You need that state. So some applications will be completely stateless. I don't care about previous results, right. For example. It's very simple. But some applications would be very opinionated about their state. They care about this. It's something that they want to do. And maintaining that state is critical. So stateful applications are critical. And we're seeing it more and more in the data streaming, and then also developers' questions come up with that as well.
And what's that last matter of time all about?
Yes, it's the notion of time. How do we handle late arriving data? How do we look at the windowing of our data? We have different ways to move the window back and forward. And you want to think, what is the best for our application, and what is the level of abstractions that we want to have? Do we want to wait for a specific amount of time to crunch that data? Do you want to do a late arriving data processing later down the road after we delivered some messaging and then go back and kind of add another substance onto it? So time really matters when we think about stream processing. And this is why the three different abstractions of event, state, and time makes Flink as the de facto engine for stream processing, because this is the core basics of how Flink is built.
And you hear a lot about Kafka, but you don't hear them as much about Flink. But they have similar, volumes of increase in terms of monthly downloads over the past, several years.
Yes, this is one of the trends that we picked up some years ago. Of both of them are being highly adopted. Some of them we hear more about, some of them we hear less about, like you mentioned. Yet people are using it. Developers are using it. The community is using it.
Yeah.
That's very interesting.
So this gives a Flink overview. Anything you want to touch on here?
I think we covered most of it. Mm-hmm. Yeah, we can jump. I think the next slide is more interesting in terms of abstractions. So something that I believe everyone who looks into Flink needs to or can benefit from understanding is the different levels of ease of use that comes, with the different levels of expressiveness and developer skills or capabilities required. So on the top, you'll see the Flink SQL. It's the simplest. It speaks to most of the data practitioners in the organization. Like I talked about before, we have the data analysts, the analytics engineers, the data engineers, the application developers, the data scientists. Everyone in this group understands and speaks SQL to a different degree. And so Flink SQL give us kind of like the easiest way to get into Flink from anyone in the organization. Well, under the hood, everything happens as streaming and online, and also there's machine learning capabilities for that. If we go in a little bit more of the expressiveness side for Python developers, there is PyFlink, and it's being highly adopted now and highly worked on as well. A lot of Python folks are very excited about streaming.
PyFlink.
Yes, not a lot of people know about PyFlink, but Python for Flink.
We'll have to look at that.
Yes. Yeah, and this is a high-level capabilities on what we have, because we asked about Confluent Cloud and Confluent Platform, and we treat them as kind of different, separate estates. When we look at Flink, on the cloud, we have the managed solution. Be connected for real-time real-time processing engine that we have. It works together with Kafka. Kafka topics are being exposed as tables where everyone who writes Flink SQL can immediately query these tables. We also have an interesting capabilities around AI model inferencing. So we noticed that also in the open source space, there was a lot of excitement around building in machine learning applications into Flink SQL. So we also built similar capabilities for folks that want to leverage that in their stream processing. And so when they build a SQL, they can already add into specific configurations to call any model inference that they want. For example, OpenAI, so they can run queries against OpenAI directly from their SQL. Or if they want to work, against any other model they're building in-house and they're serving it through a REST API, they can. There's Azure AI Studio, there's Bedrock.
It's commonly available.
Commonly available. And on the platform side, this is what we have for customers that are on-prem and for private cloud networks. So they can already use Flink together with their existing Confluent platform with little to no changes to their existing architecture around stream processing. We're also supporting customers that wants to onboard from the on-prem into new Apache Flink as well. So there's this synergy here that happens. I recently had a conversation with a big customer in the healthcare industry about how they want to move and kind of reimagine their architecture as they move some of their microservices applications into Apache Flink, and also some of their ETLs around quality assurance into Apache Flink as well, to have it as a stream processing on-prem. That's exciting things.
Interesting.
Yeah. This is the AI model inferencing. So the original Jira ticket is where the open source community in the Apache Foundation tracks.
Ah, cool.
Yes, tracks its work. So it's called, it's named Flip 437. You can Google it and see, a well-detailed doc on how how the community imagined that and kind of proposed it, and the why and how behind it. But to sum it up, it's models in Flink SQL. People want to be able to inject their inference and run it as part of their stream processing directly from their SQLs. So you can think about, for example, sentiment analysis, right? I have some data I want to quickly, that comes in as streams, for example, product reviews, right? Comes in a stream, and I want to build an alert system. And so it comes in, I'm immediately, running it against my sentiment analysis model, getting a response, good review, bad review, I need to handle it right away or not. It's automatically being called to my my alert systems that make me take care of that. Or, if the review is good, maybe I don't need to do anything. This is just a simple example of how machine learning model inferencing plays a big role in the streaming world.
Well, Adia, I think that brings us to the end of the presentation. Thank you so much for taking the time to talk to me. I've really found this interesting that where the community is going, and really this comes from the community in terms of all the ways we think about open source, these open source technologies, and the rise of Flink with Kafka and Iceberg. So thank you for your time.
Absolutely. Thank you so much for having me today. And yes, I'm excited for the future.
Great. Take care. Thanks a lot.
You too. Thanks, Alex.
Bye-bye.
Bye.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.